And then up at the top, I added a couple extra examples. So we'll start with those ones, the ones up here, A and B. So I'll give you a chance to title it and then write down those first two examples at the top, and then we'll go through those together. Okay, so the 7.1 notes, that was mostly adding and subtracting polynomials, and now we're shifting towards multiplying. So we've all learned about like the distributive property. When you have kind of like a number in front of parentheses that has a group of terms in it, you distribute that number, that term in. That's basically what we're doing today, but on like a slightly different scale. So if we look at the first example, A up at the top, it says x and then times 2x plus 4. So here we're multiplying like a monomial by a polynomial. So we'll go ahead and distribute that in order to get our product. So if we want to distribute this x in, it'll be x times 2x, which x times 2x, anytime you're multiplying like different terms like that, you multiply the coefficients, and then for the x's, think back to like our properties of exponents. So this is just a 1x times 2x. So 1x times 2x, if I multiply the coefficients, that's still a 2. And then x times x, that's x squared. So 2x squared is the product of those two. And then 1x, or just x times 4, we write that as 4x. So 2x squared plus 4x is our product there. And we can't combine that anymore because they have different exponents over the x. And then for the second one, 2x times x squared plus 6x plus 3. So when I distribute the 2x to the x squared, I multiply the coefficients number in front. So like 2 times 1, that would still be 2. And then x times x squared would become x to the third power. Remember, when you're multiplying exponents, you add, or sorry, when you're multiplying factors with the same exponent, or sorry, with the same base, you add their exponents. So x to the first power times x squared would become x to the third power. And then when I distribute the 2x times the 6x, I multiply the coefficients. So 2 times 6 is 12. And then x times x is written as x squared. And then when I distribute the 2x to the 3, 2x times 3 becomes 6x. From the 2 times 3, and then the x just tags along, so there's no other like x that I'm multiplying into it. So 2x to the third power plus 12x squared plus 6x. So that was just a recap of like the distributive property and then kind of including different properties of exponents there. So now we'll move down to example 1, where it says multiplying binomials using the distributive property. So in section 7.2, between today and tomorrow, we're actually going to learn 3 different ways to multiply binomials. This is just the first way. Today, we'll learn 2 today and 1 tomorrow. Both of the ones today are just kind of building up to the method for tomorrow. Okay, so for A, find x plus 2 times x plus 5. So it looks similar to like the first 2 examples that we did, but it's weird because now we have like multiple terms in the first parentheses instead of just one factor, one term that we're multiplying in. But we're still going to use the distributive property here. So what we're going to do is we're going to take the first term in the first parentheses, x, and we're going to distribute that by the second parentheses. So that's going to be x times x plus 5. And then now we're going to take the second term in the first parentheses, and we're going to distribute that by the second parentheses as well. So we're going to take positive 2 and distribute that by the second parentheses. So plus 2 times x plus 5. And then now we have to distribute again. So we'll do it separately. So for the first like half, or the first parentheses, x times x, that's x squared. And then x times 5, that's 5x. And then 2 times x, that's 2x. And then 2 times 5, that's plus 10. And then now that we've distributed again, all the parentheses are gone. Now we can just check for if there's any like terms. So remember, like terms have to have the same x or same variable with the same exponent. So the only like terms we have are 5x and 2x. So we can go ahead and combine those. But everything else is just going to come down. So the x squared, there's no other x squared terms. So that just comes down. 5x plus 2x, to combine like terms, you add the coefficients. So together that's 7x. And then we also have to bring down the plus 10 because there's no other constant terms to combine it with. So x squared plus 7x plus 10. And then for B, find x plus 3 times x minus 4. So we'll use the same thing. We'll use the distributive property. So we're going to take the first term, x, and distribute it by the second parentheses. So the first term in the first parentheses and distribute it by the second parentheses. So we write that as x times x minus 4. And then now we need to take the second term, positive 3, and distribute it by the second parentheses. So plus 3 times x minus 4. And then now we'll distribute again to get rid of the parentheses. So for x times x minus 4, the first half, when I distribute x times x, that's x squared. And then x times negative 4, you have to remember that the negative belongs to the 4. So x times negative 4 is negative 4x. And then for the second half, we'll distribute the 3. So 3 times x, that's 3x, or plus 3x. And then 3 times negative 4 is negative 12. And then our distributing is done. We got rid of all the parentheses. So now we just need to check for like terms. So the only like terms are negative 4x and positive 3x. So we can go ahead and combine those and bring everything else down. So x squared, I'll just bring that down. There's no other x squared terms. Negative 4x and positive 3x, if we're adding the coefficients, it's negative 4 plus 3, which is negative 1x. But remember, if the coefficient is 1 or negative 1, you don't actually have to write the 1. So we can just write that as minus x. And then we can also bring down the minus 12 because there's no other constant terms to combine it with. And then the second method that we can use for multiplying binomials is using a table. So example 2, where it says multiplying binomials using a table, find 2x minus 3 times x plus 5. I'll give you a chance to write it down. And then you're going to draw a box that has 4 squares inside of it. So the table method is kind of, it's like if you've ever taken a biology class, it's kind of like the Punnett squares that you use for like genes and genetic traits. It's just like that. So once you have your box set up, you put each factor either on the top or down the left side. So what I mean by that is the first factor is 2x minus 3, and I'm going to write that across the top. And it doesn't really matter which one goes where, like I could put that down the side if I wanted to and the other one on top. And then the second factor is x plus 5. So I'm going to put that down the side. But like I said, if I wanted to, I can switch those. And then each square in the box is going to be the product of where the column and row overlap. So what I mean by that is for this upper left box, it's going to be 2x times x because that's where those two overlap. So 2x times x is 2x squared. And then for the bottom left, it's going to be 2x times 5 because that's where they overlap. So 2x times 5 is 10x. Just multiply the 2 times 5 and the x just kind of tags along. And then in the upper right, we're going to multiply negative 3 times x because that's where they overlap. So negative 3 times x is negative 3x. And then in the bottom right, we're going to multiply negative 3 times 5 because that's where they overlap. So negative 3 times positive 5 would leave you with negative 15. And then now that we have like the squares filled in, we're basically at this step right here where we have all the terms. We just have to make sure that we combine any like terms that we have. So we're going to pull all them out of the box, try to pull them out in order of highest exponent to lowest so that your final answer is in standard form. So 2x squared. And then I can either pull out the plus 10x first or the negative 3. That order doesn't really matter because they're both just x to the first power, and we're going to end up combining them. And then minus 15. And then now we want to check for like terms. So 10x and negative 3x, those are my two like terms that I can combine because they both have x to the first power. So I'm going to bring down my 2x squared. That's my only x squared term. 10x and negative 3x, if I add the coefficients 10 and negative 3 together, that would be 7x. And then I have to bring down that minus 15 because that's my only constant term. So my final answer is 2x squared plus 7x minus 15. And then these next three examples, I want you to try on your own. So I don't have a preference which method you use. So if you would like to practice both, you can practice both. If you definitely like one more than the other, you're welcome to use that for all three. Use the one that you feel most comfortable with. So I'm gonna give you probably like 5 minutes to go through A, B, and C, maybe a little bit less, and then we'll go through those all together. Yeah, I'm just going to answer this question out loud just in case it's helpful for anybody. You can use any method that you see up here. So you can use either the first method, using the distributive method, or you can use the table. It's up to you. Okay, so for these three problems, I'm going to use both methods. So if you use a different method than me, that's totally fine. Our answer should be in the same at the end, so it should be a good way to check your work. If you would like me to like go over a certain method for something, like if I do the opposite method or not opposite but the other method, just let me know in the chat and I can do it both ways. Okay, so for A, y plus 4 times y plus 1. So I'm going to use the distributive method here. So I'm going to take that first term in the first parentheses, y, and I'm going to distribute it to the second parentheses. So y times y plus 1. And then I need to take that second term in the first parentheses, 4, or positive 4, and distribute it by the second parentheses. So plus 4 times y plus 1. And then from here, I need to go ahead and distribute again. So for the first half, y times y, that's y squared. And then y times 1, that's just y, so plus y. And then for 4 times y, we write that as 4y, so plus 4y. And 4 times 1, that's just 4, so plus 4. And then once the parentheses are gone, we don't have to distribute anymore. We just have to make sure that we combine like terms if there are any. So I have a y and a 4y that are both like terms because they both have y to the first power. So I can go ahead and combine them. So I'm going to bring down the y squared because there's no other y squared terms. And then for y plus 4y, remember that this is a 1y. So 1y plus 4y together would be 5y if we just add those coefficients. And then we can bring down the constant term, so plus 4. So y squared plus 5y plus 4. And then for the next one, I'm going to use the box or the table. So for my table, one of the factors goes across the top, so z minus 2. And then the other factor goes down the side, so z plus 6. And then each square in the middle gets filled in by like the overlapping column and row. So for this upper left, I have to multiply z times z because that's where they overlap. So z times z together is z squared. And then the bottom left, I'm going to multiply 6 times z. So 6 times z is 6z. And then in the upper right, I'm going to multiply z times negative 2. So z times negative 2 is negative 2z. And then in the lower right, I have to multiply it 6 times negative 2. So 6 times negative 2 is negative 12. And then once I have the squares filled in, I pull all those terms out and I just check for any like terms that I have. So I'm going to pull out the z squared, the 6z, the negative 2z, and the negative 12. And then I have two like terms. I have 6z and negative 2z. Those both have z to the first power, so that means we can combine them. So I'm going to bring down my z squared. 6z and negative 2z, when I combine them by their adding their coefficients, 6 and negative 2 becomes positive 4z. And then I'm going to bring down that minus 12 because that's my only constant term. So z squared plus 4z minus 12. And then for the last one, I'm going to go back to the distributive method. So I'm going to take, it's r minus 5 times 2r minus 1. This one we have to be careful with the negatives. So I'm going to take the first term in the first parentheses, r, and distribute it by the second parentheses. So r times 2r minus 1. And then I'm going to take the second term in the first parentheses and distribute it by the second parentheses. I just have to be careful because this is a negative 5. So I have to distribute the negative along with the 5. So that'll look like minus 5 times 2r minus 1. And then from there, we'll distribute the first half. So r times 2r becomes 2r squared. And then r times negative 1 is just negative 1r or negative r. Remember, we don't have to write the 1. And then when I distribute the negative 5, I have to distribute the negative with the 5 both times. So negative 5 times 2r is negative 5 times 2, so negative 10r. And then negative 5 times negative 1 is positive 5. So negative times negative turns into a positive. And then from there, we just want to check for any like terms that we have. So we have 2r squared minus r minus 10r plus 5. The like terms are the negative r and the negative 10r because they both have r to the first power. So I can bring down my 2r squared, negative r and negative 10r. If I combine those, this is like negative 1. So negative 1 and negative 10 together is negative 11r. And then bring down the plus 5, the constant terms. There's no other constant terms to combine it with. So 2r squared minus 11r plus 5. So that's it for today's notes. That was the first two methods for multiplying binomials. We'll learn